Okay guys, welcome back to GDEX Academy. I want to first thank you all for viewing most of our videos. I really appreciate you are doing a great work here. So what I have for you guys today is functions. So what I have for you today is functions. So as you can see, function is a mathematical way of describing a relationship between two or more variables. In other words, it is a mathematical expression involving one or more variables. Functions are useful in business and commerce, where fragments of information can be connected together by functional relationships. And that is what we'll be focusing on today, the application of these functions. But before that, let me quickly dive into the explicit and implicit function. Stay tuned. So implicit function is a function where one variable is directly expressed in terms of the other variables. For example, what you are seeing here, this is an example of an explicit function. Y is equals to 5x plus y. So it's an example of an explicit. For an implicit function, it is a function when the relationship between the variables is expressed as an equation involving all of the variables, that is x and y. For example, 2x squared plus 3xy plus 3y plus 10. This is an implicit function. Then we have types of function, which are linear function, quadratic function, exponential function, and logarithmic function. So I will just variables are of first degree and is generally of the form f of x equals to a plus bx. So you can also say that the linear function is one in which the highest power of the variable x is always 1. So once it exceeds 1, it is no more a linear function. For example, y is equals to 18 minus 2x is an example. You can notice x here is the highest power of x here is 1. So for the equation here, for the format, a and b is constant. A and b are the constant, and the power of variable is always 1. So that's that about linear function. Then we move to quadratic function. For quadratic function, it is one in which the variable x is of second degree and is generally of the form y is equals to ax raised to power 2 plus bx plus c, where a, b, and c are constant and a must not be 0. So for quadratic equation, the highest power here is what? 2. The highest power. So once it exceeds 2, that means it is no more a quadratic function. Then you can see an example, y is equals to x squared plus 5x plus 6, y is equals to 16x minus 3x squared plus 1. It can come in different form. As for exponential function, it is a function which has a constant base and a variable exponent. For example, if y is equals to a raised to the power of x, then y is said to be an exponential function of x. A is the base and x is the exponent. So it is a non-linear function. If a exceeds 1, there is an exponential growth. But if a is less than 1, there is an exponential decay. Most of exponential functions used in economic theory have the base as e. Values for exponential function with the base e are easily obtainable from the statistical tables or by the use of a calculator. Then as for logarithmic function, it is another non-linear function and is of the form of y is equals to ax raised to the power of b. If the logarithm of both sides are taken, then we will have log y is equals to log a plus log b raised to the power of x. So y is said to be a logarithm of function of x, where x is the time period. Then the graph of a logarithmic function cannot be easily drawn except if the value of a, b, and x are unknown. But I'm not going to be going into graph for today. Perhaps maybe in another class. For each and every of the types of function that I've explained, there's a graph for it, but I won't be doing that. What we'll be focusing more on the application of it into a business. So here's our main focus for today, that is application of our functions to business, economic and management problems. But before I move into it, some of you guys might be confused on function, on how it is. Some are saying maybe it is an equation or it is a function. So the difference is that for an equation, it is a mathematical expression of two equal quantities, while for a function, it is just a way of describing a relationship between two or more variables or quantities. So for equations, they will be equal, but for function, they don't have to be equal. I hope I have cleared you guys on that. So now back to what we have for you guys here today, which is the application of functions to business, economic and management problems. We have our cost, our revenue and profit function. So we started from our cost function. For our cost function, we have our fixed cost and our variable cost. Our fixed cost representing the capital cost. It's also referred to as the capital cost. Then our variable cost, that is like our cost of materials, labor, utilities, etc. The fixed cost is always constant and it represents the setup cost, while the variable cost depends on the number of units produced or purchased. For example, so these are the functions here. We have for linear and for quadratic. So I would have written quadratic for you guys. So it depends. For linear, A here is the fixed cost. Then for our quadratic, our C here is the fixed cost. I hope you guys are clear on that. So I'll be diving into an example for you guys for our fixed cost. Alright, the cost of renting a shop is 120,000 naira per annum, and an additional 25,000 is spent to renovate the shop. So you are told to determine the total cost if the shop is to be equipped with 480 items at 75 naira per item. Alright, here's our solution to this. Note, so the cost of renting a shop, that's setting it up, that's where our fixed cost. That's 120,000 naira. And an additional 25,000 is spent to renovate the shop. So making a total of how much? Put your naira sign, or your currency sign rather. That will be 145. The cost here is what? Our variable cost here is, if the shop is to be equipped with 480 items at 75 naira per item. So this is our variable cost, 75 naira per item. Therefore, bringing out our format, A representing our fixed cost as what? 145,000 plus our B representing 75 naira. So these are our cost function. So we are told to look for the total cost if 418 items is to be equipped by the shop. Therefore, it's not in our brief results. Total cost is 145,000 plus 75 into brackets 480. Therefore, our total, if you multiply this, our total cost is 181,000 naira. That's our total cost. So without wasting much of our time, move to our revenue function. R of the function of X represents the income generated from the sales of X units of an item. So the our revenue function is totally depend on X and is always of this form. Okay. Then R is equals to price multiplied by the variables x, where p is the sales price of the item. Alright, so for example, if 2,500 items are produced and sold at 220 naira per item, calculate the revenue that will accrue from the sales. Okay, so our revenue is equals to the price times quantity, which represents x. Therefore, our price here is what? So our x here, which is the quantity, is what? 2,500. Therefore, our revenue here is 120 times 2,500. So we multiply this by this. You have 300,000 of revenue. As simple as that. So revenue there's nothing like fixed revenue. You just have to work for it. Then our next on line is our profit function. So our profit function here of any project or business, it is the difference between the revenue function and the cost function. So it is the difference between our revenue function and our cost function. That's what our profit function is. Alright guys, so I have a standard question for you guys, and it says a businessman spends 1.5 million naira to set up a workshop from where some items are produced. It costs 450 naira to produce an item, and the sales price of an item is 1,450 naira. Find the minimum quantity of items to be produced and sold for the businessman to make a profit of at least 800,000 naira. Wow. You are free to press the pause and give the question a check and try it out before you play on and continue the video. So keep watching. So here is our solution. I can zoom out now for a better view and adjust it up. Okay, so our cost here is, so I won't be wasting much. So our fixed cost here is 1.5 million naira plus it costs 450 to produce an item. That's our variable cost. Remember, it always comes with X. Then for our revenue function, the sales price is what? 1,450. X, no, is times X. So this is the sales price versus our variable X, which is the quantity. So to get our profit, like I explained earlier, it is revenue function minus cost function. Therefore, it will be 1,450x minus so you expand, you take off the bracket. You have 1,450x. So you can easily bring this here 450x minus, because minus times plus give us minus 1.5 million naira. So our profit function here is $1,000x minus 1.5 million. So this is our profit function. So the next on the list is we have to determine the minimum amount of quantity of items to be produced and sold for the businessman to make a profit of at least 800,000 naira. So at least there must not be less than this. So our profit here will be 1,000x minus 1.5. So it must be greater than or equal to 800,000 naira. Therefore, you collect like times here. That will be 1,000x greater than or equal to 800,000 naira plus 1.5 million naira. So this 100,000x is greater than or equal to 2.3 million naira. So you divide both sides by x. I remember in law of inequality, once it is divided or multiplied by a positive integer, the signs remain the same. So you divide both sides by 1,000. Our x here is greater than or equal to 2,000. So therefore, for us to make at least the profit of 800,000, that means you have to sell an item of 2,300 items must be produced and sold to make a profit of at least 800,000 naira. So that's the end of our video. But before we close this video, so I will quickly love to brief you guys on the relationship between our revenue and our profit. So once your normal profit here is revenue minus cost. So if revenue is greater than our cost, then we have a profit. That is a positive balance. But if our revenue is less than our, but if our revenue is equal to our cost, that means there's no profit or there's no loss. Call it autonomous profit. Therefore, this is what we call the break-even case. So there's a graph for each and every one of these too, but like I said, we won't be going into graph today, maybe some other time. So thank you guys for watching our videos. Kindly like and subscribe to our channel and share our videos. Invite your friends so they can also learn too. Thank you very much. Have a good day.